In today's video, we will review simplifying square roots and then using the square root method. So simplifying roots is something that you've done before in geometry and algebra 1. The square root method has to do with simplifying square roots, and it's another way to solve quadratics. So starting with simplifying square roots. This first example, simplifying the square root of 48. This is something you've done before. There's two different methods. First method is to look for pairs of numbers. Here's what I mean by that. If I take the square root of 48, I'm going to break it down as much as I can to all of the prime factors. So 48 is 4 times 12. 4 is 2 times 2. I can't break that down anymore. This 12 is 4 times 3. And again, 4 is 2 times 2. So now I'm looking for all of the pairs of numbers that I have. In this case, these 2's are a pair. These 2's are a pair. And I have the 3 left over. The numbers that have a pair go outside. So 1, 2 goes outside from this pair. 1, 2 goes outside from this pair. This 3 that's left over stays underneath the root. So 2 times 2 is going to give me 4 root 3. So that's the first method for simplifying square roots. Second method is to look for perfect squares. What do I mean by perfect squares? Perfect squares would be 1, 4, 9, 16, 25, etc. So 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, etc. So in this case, the largest perfect square that goes into 48 is 16. So 48 is the square root of 16 times the square root of 3. Square root of 16 is 4, and then I bring the 3 with me. Now, both of these are valid methods. Method 2 is going to work really well if you know your perfect squares well. So if you have your perfect squares memorized and you can see them as factors, you're going to want to go with method 2. If you don't remember those perfect squares or you don't always see them, method 1 might be better for you. So as I said, my preference is method 1 to look for pairs of numbers, so that's what I'm going to do. If I look at this first example at the bottom, the square root of 40, I'm going to start this by breaking 40 up into prime factors. So 40 is 4 times 10, 4 is 2 times 2, 10 is 2 times 5. So next what I want to do is I want to look for the pairs. These 2's are a pair, that 2 and that 5 are left over. The 2's that are the pair go outside the root. The numbers that don't have a partner go underneath the root. So that's 2 times 5. That 2 times 5 then becomes a 10. So my final answer is 2 root 10. Again, that's just one possible way of doing the problem. That's method 1. If you want to do method 2, you can look for perfect squares. If we look at this 6 root 20, again, I'm going to start by breaking up the 20. 20 is 4 times 5. 4 is 2 times 2. Now, I should mention, this is just one way of breaking up 20. If you choose 2 and 10, you're going to end up with the same answer. Your breakdown is just going to look different. So if I look for pairs, these 2's are a pair, that 5 is left over. The 4 I don't need to worry about because I broke it down. So the 4 I can ignore. So that root 20, the 2 comes outside the root, the 5 goes underneath the root because it doesn't have a partner. I can't forget about the 6 though. The 6 is still outside. So 6 times 2 then ends up being 12 root 5. So what I want you to do right now is I want you to pause the video and I want you to do the 2 examples to the right. Okay, let's see how we did. For the square root of 72, I would have broken that up to be 9 and 8. 9 is 3 times 3. 8 is 4 times 2. And then I have a 2 and a 2 again. If I circle my 3's, circle my 2's, 1 3 comes outside, 1 2 comes outside, making it a 6. This 2 that's left over goes underneath the root. For the next example, you should have broken down the square root of 50. The final answer ends up being 15 root 2. If you didn't get that, you need to go back and find your mistake. If you come to class tomorrow and you do not have work for this problem, you will not receive credit for the notes. So that was reviewing square roots. Now, why do we need that? Well, we need these square roots so that we can use the square root method to solve quadratic equations. So please flip to the next page. Okay, so we are going to use the idea of simplifying square roots to use the square root method. Square root method is another method for solving quadratic equations. Now, it can't be used for every quadratic equation, though. You're only going to use the square root method when you have a squared term and no x term. Okay, now I know that that's a little confusing. Here's what I mean. If you have x squared plus 4 equals 0, for example, we have a squared term. We don't have an x term, though. So in this case, we could use the square root method. But if I have something like this, x squared plus 3x plus 4 equals 0, in this case, I have a squared term and I have an x term. So I would not use the square root method here. So you're only going to use it when you have a squared term, but no singular x term. So if we look at example 5, can we use the square root method? We have a squared term. We have no term that has just an x. So in this case, we can use the square root method. Let's look at our steps here to the left. First step is to isolate the squared term. So that part that I underlined, we need to get alone. So I'm going to subtract 10 from both sides. I have 2 times the quantity x minus 1 squared equals 64. At this time, some people are tempted to distribute that 2 in. You can't. Order of operations, you can't distribute the 2 in. We want to get rid of it. So you're going to divide by 2. So I have x minus 1 squared equals 32. Okay, so that was step 1. I isolated the squared term. Now I need to take the square root of both sides, because that's how I'm going to get rid of the squared. When I do that, on the left side, I have x minus 1. On the right side, I'm going to need to break down that square root of 32. So if I look for pairs, this is 16 times 2. This is 4 times 4. This is 2 times 2, and 2 times 2. I have a pair of 2's and another pair of 2's. That becomes a 4. And then that root 2 comes from that 2 that's left over. Now, here's the thing that you cannot forget. Anytime you take a square root, you're going to get 2 answers, a positive and a negative. So anytime that you put the square root in, which I did here, the square root wasn't there, I took the square root, I'm going to get a positive and a negative answer. Now I need to solve for x still. So when I add 1 to both sides, I get x equals 1 plus or minus 4 root 2. So that's my final answer. Now, this is really 2 answers, 1 plus 4 root 2 and 1 minus 4 root 2. Now, how do we know that we need to have 2 answers? Well, that's what that x squared means. X squared means you're going to have 2 answers. X to the third would be 3 answers, x to the fourth would be 4 answers, etc. I know that that's a little confusing, so we're going to do another example before I have you all try one on your own. And it's example number 6. Okay, so again, we need to ask ourselves, can we use the square root method here? Well, yes, we can. We have an x squared term and we have no x. So that's good. First thing we want to do is get that x squared alone. So if I add 5 to both sides, I get x squared equals 64. I still need to divide by 4 because I need the x squared alone. I get x squared equals 16 in this case. Now that I have the x squared alone, I can take a square root. So I get x equals 4. You have to remember, though, the plus or minus. Anytime you take a square root, you're going to get 2 answers. And again, your original problem was x squared, so you should get 2 answers. Now, solve for x. Well, x is already alone, so this is our final answer. X equals plus or minus 4. Right now, I want you to pause the video and do example 7 on your own, please. Let's see how we did. First thing you should have done is check, do I have a squared term? Yes, I don't have a linear term, I just have a squared term. So I'm going to start by getting that alone. If I add 4 to both sides, I get y plus 3 squared equals 52. Take a square root. So So I get y plus 3 equals plus or minus. Now, on the right side, you should have simplified that root. When you do, you get 2 root 13. If I solve for y by subtracting the 3, I get negative 3 plus or minus 2 root 13. That's my final answer. Now, word of warning, these cannot be combined. One has a root, one does not. You cannot combine those. So you should leave them as 2 separate terms. Hopefully that went well. If it didn't, hopefully you now see what mistake you made. What I would like you to do now is pause the video again and do example 8, please. Let's see how we did. You should have gotten m equals 7 and 1. If you didn't get that, please go back and find your mistake. If you have any questions, please make sure you bring them to class tomorrow.